Hello, grade 9. How are you today? I hope you all are safe and well. We studied before about hot and cold and the difference between energy and temperature. So we said about the temperatures that is measure of how hot something is or cold something is. And we can measure it in degrees Celsius with a thermometer. And we mentioned also that energy could be transferred from the thermal energy can be transferred from the hot side to the cold side, or the more hot material or side to the less cold or less hot side or cold side. And we mentioned that how much energy does it take to raise the temperature of an object. That depends on three things, which is mass of the object, what is it made of, which material it's made of, and the temperature change that we want. And also we said when we heat up a solid, liquid or gas, the motion of the particles change. So today we will talk about the energy transfer. So how can the energy transfer? We will first start with the part of conduction. We studied about conductors and insulators before, but how can these conductors and insulators work, and why do we call them conductors and why do we call them insulators? We studied before the conductors that allow something to pass through it, whether it is thermal energy or heat, like heat, or electricity. And we said insulators, we prefer to something that block the way for anything to pass, like doesn't allow the heat or the electricity to pass through it. So open your books on page 206 and follow me. Thermal energy. Neela wants to light a Bunsen burner. She takes a piece of wood called splint. So this is the splint, okay? This splint, they are using it to support like broken bones or something, okay? And she lights it from the teacher's Bunsen burner. She carefully carries the splint back to her Bunsen burner and lights it. The splint is on fire at one end, but she can hold it without burning her hand. This is because the thermal energy is not transferred down to the splint to her hand. So here we can name this piece of wood insulator. Why? Because the fire or the energy from this side doesn't transfer along the wood piece to the hands. Okay, what about the conductors and insulators? So now we will see how can materials conduct heat and insulate heat. Thermal energy is transferred through a solid by conduction. Some solids conduct thermal energy better than others. We all know that metals is the best choice, but some metals are conduct energy, thermal energy more than others. So metals are very good conductors of thermal energy. Copper is the particularly good conductor of thermal energy. And saucepans are often made of copper. It quickly conducts the energy of the food in the saucepan. So that's why they're using the copper or sometimes aluminum in saucepans, because they are conducting energy so quickly. So they can pass this energy to pass through them, allow the energy to pass through them very quickly. Many non-metal are poor conductors of thermal energy. They are insulators. Like what? Like the spoons, the wooden spoons that we are using. This doesn't mean that they do not conduct at all, but that thermal energy is transferred very slowly through them. So they can transfer energy, but very slowly. You can do this, you can try this, if you placed a plastic spoon or wood spoon in a saucepan and leave it for hours in a very hot place or a very hot pan, you can feel it like a little bit warm because the energy has transferred to it very slowly. But not like the steel ones or the metal ones. They can conduct heat or energy quickly that they can burn your hands. Materials such as paper, cloth, wood, and plastic are all insulators. The handle of saucepans are often made of wood or plastic, so you do not burn yourself. So that's why they're using insulators. Okay, we talked about insulators. So why sometimes we are feeling something cold or warm? Bicycle handlebars are made of metal, but the end of the handlebar are often covered in plastic. So if you touch this metal, you will feel it cold, but if you touch this plastic, you will feel it warm. Actually, they are the same temperature, but why we are feeling the insulator warm and the conductor cold? When you put your hand on the metal, it feels cold, but plastic doesn't feel cold. Neela puts her hand on the metal of her handlebar and then on the plastic. Like Neela did, it's tempting to say that objects are at different temperatures if that is how they feel to us. However, our skin is not a very good thermometer. It detects the transfer of thermal energy rather than the temperature. So we cannot measure the temperature with our hands, but we measure the transfer of thermal energy with our hands. So when she puts her hand on the metal, thermal energy is transferred away from her hand to metal. Why? Because her hand is warmer than the metal. So she says it feels cold, because we said when the energy transferred from one side to the other side, it will lose energy. So your hand, it's like ice cube. If you put it in your hand, you will feel the cold. Actually, the energy transferred from your hand to the ice cube, so the same thing happened here. The energy has transferred from her hand to the piece of metal. In this case, she lost some energy in a specific spot in her hand, so she felt cold. When Neela puts her hand on the plastic, here the thing is the matter here is opposite to the metal, is different. The matter is different. So thermal energy is not transferred away from her hand because the plastic is an insulator. She says it feels warm, though it's at the same temperature as the metal. So if you put your hand on something hotter than your skin, like a stone that it's in the sun, it feels warm. Why? Because the energy moves from the stone to your hand, so it feels warm. But if your hand is warm and the stone is cold during the night, you will feel it's cold because the energy has transferred from your hand to the stone, so it will feel cold. So now let's talk about the conduction and particles. So what's happening inside the materials, or how the particles behave when they conduct heat. The diagram shows a piece of metal being heated at one end. The metal atoms on the left are vibrating a lot, and the atoms on the right are not vibrating very much. The left end of the bar is hot and the right end of the bar is cold. So thermal energy is being transferred from the left to the right. So here the heat source, okay, is heating this side. So if you are feeling your hand here, if you are putting hand in this side, you will feel it warm after a while. But if you put your hand here, you will feel it more hot but if you put it here, you will burn yourself. Well, what's happening exactly? The thing that when you heat the solid, the particles start to vibrate. Okay? Then, if you go away from the heat source, the vibration will decrease, and so on. So as you are going further away from the source of heat or the source of thermal energy, the vibration will be less. So in this case, you will not feel the heat or the temperature. Okay, so what about the conduction in liquids and solid and gases? Liquids like water and are poor conductors of thermal energy compared with solids. Okay, this is a good question. Why? So liquids are poor conductors compared with solids. Why? I'm gonna leave you with this question, and I need your answers about this. Okay, give me your answers and we will check it, or I will check it. So you can see this. If you heat one end of a test tube of water, an ice cube held down by a weight will not melt even if the water at the top is boiling. Exactly like this in this picture. Here is the ice cube, and they are placing a weight on it, not to make it float, because it's less dense than water and in the solid state. And the water is boiling here. So why the ice cube is not melting? This is because the water is poor conductor, so it will not transfer the energy immediately to the ice cube. So what about the divers? Why they are wearing a wetsuit? So a diver wears a wetsuit to dive in cold water. So we all know that this suit to protect the divers from the coldness or from the temperature, the low temperature of the sea, under the sea. So how does it happen, or how this is happening? The wetsuit uses water as an insulator. It holds a small amount of water inside it, so it allows a small amount of water to get inside it, forming a very thin layer between the driver's skin and the rubber of the suit. So the rubber can get the coldness, but here the layer of the water under the rubber will act like a barrier. It will act like a barrier to hold the temperature out. So the body temperature will stay stable. So the water is not free to move around. So here the water is stuck under the suit, so it will not move. So thermal energy is not easily transferred from the diver to the sea water, so the diver does not feel cold. So the body temperature is warmer or more than the body temperature is more than or warmer than the water of the sea. So this water can keep the body temperature stable. The body will not lose its energy, so the diver will not feel the cold. As well as these suits or these clothes. Air is a very good insulator if it's trapped and cannot move. So here in these jackets, they are using kind of cotton, so it will suck the air in. This air will work exactly like the water in the wetsuit. It will block the air out, or keeps the body temperature stable, not losing a body temperature. It's used in materials that are designed to keep people warm. Clothing and bedding can be made from materials that trap air. So they are using materials can block or can insulate air in clothing and bedding, like the bed materials to make the bed mattress. Gases such as air do not transfer thermal energy because their particles are much further apart than the particles in solid. So this is the reason that gases are not transferring energy, or we can name them insulators. Okay, now let's go to the summary of the lesson. Energy transfer. Conduction. Thermal energy is transferred through solids by conduction. Metals are good conductors of thermal energy, but plastic and wood are poor conductors. And we said that means they don't block, or they don't insulate the thermal energy at all, but they are slow transferring for energy. Liquids and gases that are not free to move around are poor conductors of thermal energy. Poor conductors are called insulators. So this was about energy transfer conduction. I hope you understood the lesson. If you have any question, write it down and write these notes in your notebooks. Don't forget the yellow box homework, and see you next time in a new lesson. Bye-bye.